Alright, so I went and quickly disassembled this motor. This motor I had, well, it doesn't even have the actual motor. We'll call it a gearbox. So I disassembled this gearbox. Did it in a kind of a dirty spot, so these gears are dirty as hell. If I needed this gear set for a backup, yeah, obviously I'd have to clean it up before we use it. So I don't know how much you guys have been tearing stuff apart, but if you tear apart a little servo, these guys right here, if you tear one of those apart, you're going to see a gear set very eerily similar to this. The only thing difference between that, obviously, okay, fine, size of the driver motor, and B size, like, of everything. But these guys don't actually have a sensor feedback because they didn't need it. These are actually gearboxes, power motors out of a cheap Chinese version of a Power Wheels. So this is what the gear set looks like when it's all together. We'll just slap her together here. Get everything meshed together. We don't want to mess around with the gears too much with all that metal shavings in there. So yeah, you got there we go. The motor pinion sits in that hole. Let's give it a little light. There we go. You can see the hole now. So the motor pinion comes out of there and it drives that big gear. So it's another big gear, little gear, and then little gear, big gear, little gear, big gear. So yeah, it's a pretty decent gear drop. I didn't do the calculation, didn't really care. I know that this motor, based on a 5-inch wheel, let's put that over there. Is it 5? Yeah, I think we measured the wheels at 5 inches. 5-inch wheel could actually carry my 220 pounds around, no problem. Yeah, uphill it had problem, but on flat ground we're talking no problem. The output that this guy is going to have is actually, right here. So here's our output. It's a number 50, schedule 50, whatever the hell you want to call it when you're talking about chain size. It's a number 50 chain. That sprocket, not welded yet, but significantly smaller than 5 inches. I think we'll have enough torque out of this guy to achieve what we need out of the Dozer. Worst case scenario, this is all a waste of time, and the only thing I got to do or that achieved out of all this, let me get a bearing, is we figure out our bearing locations. Because yeah, we're gonna have bearing on the outside here, another bearing on the inside. It's not a very long distance between the two bearings. I'm hoping it's going to be enough support for the axle. I did have another idea, but it involves a lot of modifications to the back of the motor housings, and I wanted to keep them as intact as possible. But like one of the things it requires is me to remove this rib here. If I remove that rib there, I think, because like this is the backbone of that plate there. So I think I might weaken that too much if I took those tabs out, even though I know that these tabs were actually to keep the motor from rotating on the Power Wheels. That's what kept the index. So yeah, long story short, these have a really decent output speed. I think they'll suit the Dozer quite nicely. If we find them a little slow, we might be able to upgrade these 540 can motors to maybe even brushless if we want to go that route, but plastic gears, I don't know if they'll hold the brushless. We'll cross that bridge when we get there. We gotta get the thing together first. So, how I figured out, what the whole point of me showing you the inside of this gearbox. Let's get her apart again. This middle gear likes to stick. And of course, I got my hands full of camera now. Alright. That crap out of the way. So, as I mentioned before, this is a 5/8 shaft. The original, Power Wheels come with a 1/2 inch shaft. The 1/2 inch shaft goes through there, and it actually, the motor doesn't rotate the shaft. It actually has this bolted to the wheel, and the axle slides through here and only carries the weight of the wheel. What turns the wheel is actually this guy splining into this output right here, actually. So once you drill out this shaft, or this axle or bushing or whatever you want to call it, you put a 5/8 hole in there, and that becomes super thin. Be able to show you how thin that looks like, because well, I figured if it's going to be plastic and it's going to have that thin of a wall, a metal one might hold up. I was thinking steel at first, but you know, it's easier to machine aluminum, so we could try that first. And I have some special aluminum that's formulated just for machining. It chips instead of makes big long strings. It's actually a pleasure to work with if you ever work with some regular aluminum. So let's see if we can focus on. Yeah, it's not going to show in the camera very well, but either which way, you can tell that is much thinner than that. So, but now our 5/8 shaft can go through there, and we can actually hook our wheels, our output sprocket to this guy. So now, all we have to do is we can take this shaft, and I'll show you you kind of saw how the alignment actually works before I pulled it apart. So now my shaft can spin inside there, right? So we got a hole there, and we got a little hole there. So my plan is to drive a pin through that hole, through the shaft, and that will make the shaft and this adapter one. Then I'll be able to slide it back in, and those two will be locked together. Now, the other thing is, I should mention here, the shaft's going in backwards right now. This motor will be spinning. The shaft coming out this side here. I gotta zoom in. There, let you suck for a sec. But that's more or less of what I want out of this. Now, the only reason why I wanted the shaft to still come through and maybe even protrude out the backside here a little bit, is just so it gets a little bit more stability, because as aforementioned, the distance between my two bearings holding this shaft square or true, or however you want to put that, it's not that great. So yeah, I figured a little extra support may not hurt. Okay, so that is where we're at so far. So I will clip you guys back into the stand so I don't have to hold this, and I can actually whip this thing back together. You know what, you guys are going to be able to snap, and I might edit it out afterwards. If not, what? Oh well. So, there we go. So another little quirk I found about these motors, and I found this out quite early on. So if you rotate them with such, they will actually, they don't like fully interlock, but they allow themselves to get close enough that you can actually see where that shaft will protrude on the inside, and it gives it a little more stability. So I haven't really cared which one left or right is going, because as we mentioned, the only difference is how the wires are wired. The only reason why I did it, I made sure I actually have 4 of these motors on. Well, you've seen 3 of them. I don't know where the 4th one is at the moment. It doesn't really matter. I got 2 working, modified, ready to go. One's here. So I did try to make sure I got a left and a right. And that's the only reason for that, is just to make my wiring a little more simple. I'll know that we'll call adding positive to the red wire, we're going to call that nominal driving forward. We'll find out if I'm right or wrong about that. It doesn't matter. But I can still put the positive lead from the ESC on both motors, and they will be spinning together in the right direction. Unless I'm totally wrong, and then I'm just a big fat liar. So we've just slapped the motors in there for now. We gotta go through a bearing. Oh yeah, all this was nice and shiny, brand new when I bought it, so and it gives me an idea how long it's been sitting. Just move those out of the way for now. I'll grab another bearing. So, other bearing. And my intention is to mount both of these. You'll see they got a little bit of a gap. The bearings aren't sitting square in the housings. That'll be straightened out when I go to clamp it all together. You can use percussion force too to fix that. Anyhow, we're not in our final setup yet, so we need to get there. And this is how I figured out how to get there. So slide that back. I've always been trying to, just so I keep putting it together the same way. Oh yeah, hey, maybe we should demonstrate that that's good. Yeah. I've always been putting the left-hand motor, from a driver's perspective obviously, but the left-hand motor, I've always been making that one face back. No particular reason other than the fact that I'm putting it back together the same way every time. So, essentially, that's how it's going to be. Slide, oh yeah, we're going to have a collar here. This actually has a little bit more room to go that way. And a little collar here. You guys can't see that really well because it's hiding. Got a little collar here. Only said that. Do I need to say it again? You got a little collar right there. That's actually to lock the bearing for the shaft. Oh, I did that backwards again. So this guy's intended to go about there. I don't know how well it's going to line up in the camera, but I just kind of fluked out. This wasn't pre-measured for this. This is actually okay. Fine. The original power plant for these outputs were supposed to be hydraulic spinner motors. That's what dictated my width. Is that you could fit 2 Princess Auto spinner motors here with their output. You would have to actually cut out, like use a hole saw, cut out like a I think it was 2.5 inch hole, and then I think it had 4 mounting bolts. So it'd be same number of holes, but that center hub would actually help center the spinner motor. And we're going to tension on the tracks just like a real piece of equipment. I think on the real deal, the front idler is the one that actually tensions your tracks. I could be wrong, but we're going with that. Possibly even using a grease piston, just like the real deal. But we'll get there when we get to the tracks. So anyhow, long story short, that's basically how this will be, and then it'll get chopped off there, and we got hooked up. But to make sure everything stays in line, my plan, see where we warmed up here, my plan, we're gonna have to take everything off here. Push that out a little more. I don't have the other 4 bearings ready yet, or the other 2 bearings yet, so ready yet. We'll call that good now. So there is a little bit of tension. I can tell that my hole on the passenger side, the right side of the piece, or the piece of equipment, is a little low. I haven't done this any scientific method, or I haven't done pre-measurements. This isn't designed in CAD. This is me grabbing parts and making sure they fit. So yeah, things happen like this to me all the freaking time. Shout out to Winter Gayton and the Marble Machine X. Yeah, there is no way in heck I will go and pre-engineer this damn thing to make it work. I could spend years doing that and then still not having a running machine. In fact, that was part of my hang-up, is me just trying to figure out everything before we build. My plan is to basically just get the damn thing running. There's no other way to put it than that. I'm gonna try and get this damn thing running through hell or high water. And we'll take a little bit of Winter Gayton's ideas, and we will take it step by step. We're not gonna look at the whole dozer yet. I will give you guys a little overview of some of the other systems there. We like I said, we're going with hydraulics on the blade controls. I got a cheap Chinese hydraulic system for an RC conversion kit. It'll do the job. I think it's actually a little overpowered for what the job is. It's meant to run an excavator, but yeah, long story short, yeah, fine, let's grab the hydraulic system. There's not much to it. Just give me one more sec. So with every hydraulic system, we got a tank. Got a pump sucks from the tank, supplies flow to the control valves. These control valves, I've had a very, very, very fun time making sure that the servos are aligned with the actual valve actuator. They tend to stick up when you screw everything in tight. Don't ask me what part is misaligned, because I try to figure that out myself for many, many times. I just found you end up just leaving one of the plates loose. Can't remember which one it is. It looks like it's this guy here. You leave him just a hair loose, and then these servos spin those valves, no problem. I have thought about maybe looking at the plastic cups. Maybe they're interfering too much. Like I just maybe got to shorten them just a little bit. So yeah, there's the basic system. 3 valves. I do wish I had another one, but this should suffice for now. Blade up and down on one, tilt on the other, and ripper up and down. I did want to put a ripper angle in, but over being able to take the blade and tilt back, and having my ripper being able to have multiple angles, I think I'm just going to use different pin positions for the ripper to change the angles. Old school mechanical setup. So there ain't much to this. And then we got some hydraulic, hydraulic rams. They're really not nothing special. The only thing that sucks about these guys is they are built out of, I actually haven't even measured it yet, but I'm pretty confident that this is 12 mil copper tubing. It might be 13, but this is 1/2 inch copper tubing. And I don't know how well this is going to show up. So I machined this guy down to fit the caps from these guys. And the whole reason why I wanted to fit the caps from these guys is I haven't found a good way to do a seal head myself. Still trying to figure out a way to cut an ID seal and be able to attach it to the copper easily. So yeah, something I got to think about. So yeah, long story short, the hydraulic system is pretty well figured out with these guys. I think this repair modification to make, because I'm going to need longer rams. Copper tubing has pretty decent QC, I guess you could call it. Like, there isn't a lot of big variation on the ID of these guys. So I think yeah, I think the hardest part is going to be making longer rams. I've successfully done it once, so we can try again. The other thing to mention, not really the best hydraulic seal. This is a grease seal basically, because like, I don't know if it shows up in the camera at all, but there is a spring in there, just like a grease seal. Whatever, we'll see if that works. Yeah, if I start having big leaky problems, I will redesign the seal head, because that can be a potential problem. So yeah, that's it, the project at this point in a nutshell. Now, the plan ahead, or going ahead with this, doing this on YouTube, I'm not trying to make $1 million, like, well, some of the YouTubers I have out there, like, you know, the Linus and the Wintergaden and the, yeah, you know, all them popular YouTubers. This is more or less me trying to figure out how to get this thing running, and I just wanted to kind of put it out there. So yeah, I guess this is our RS10 guy signing off, and we'll see you on the next one. We'll see it, and we'll probably knock out some of this knock out the progress on this guy, and at least have these motors mounted, and maybe we can or get cut some idler wheels and hook up the chain, see this thing run. Not properly, but like, we'll I can rig stuff up. We'll just go with that. Well, I can rig some stuff up. It may not be pretty, but it'll get the job done. Anyhow, like I said, see you guys next time.